Hi, this is King and Neundorfer of Mr. Ahmed's Honors Chemistry B period class. Today we will be exploring Boyle's Law and Charles' Law of gas. For the first experiment, we will be taking a deeper look into Boyle's Law of gas, which states that pressure and volume are inversely related, and that when the pressure goes up, the volume goes down, and vice versa. Boyle's Law of gas can be calculated with the following equation: P1V1 equals P2V2. P1 will be the original state of pressure before the experiment, and V1 will be the original volume. P2 would be the pressure after the experiment, and V2 will be the volume after the experiment. In the second experiment, we will be examining Charles' law of gas. Charles' law of gas states that temperature and volume are directly related, that when the temperature goes down, the volume will go down. The equation you use for Charles' law is V1 over T1 equals V2 over T2. The materials that we will need for this lab is a pre-blown up balloon, a large glass bowl of water, and some sort of thermometer. I'm using a digital infrared thermometer to get accurate readings. So let's move on to the experiment. First, what we must do is find the volume of this balloon. How we will do that is we will mark off with, I'm going to use a piece of tape, mark off right about where the initial water level is. Next, what we'll do is fully submerge the balloon. As you can see, the balloon goes almost to the top. I'll mark off where it was at. Just a little bit from the top, right about there. Okay. Well, so the volume of what we will do is find the volume of the balloon by subtracting the amount of water from here by the amount of water from here, which is called displacement. What I'm going to do is just use a regular measuring cup to measure the amount of liquid in the bowl. So what I will do is just fill up each. How I will find the volume of the balloon is I will take this water here and put it in this measuring cup and just figure out how many milliliters of water is in here. So that's 500 milliliters. $1,000 milliliters. $1,500 milliliters, and about not even 100 milliliters. I'm going to guess that as 72 milliliters. So we have 1,572 milliliters of water to this line right here. Now what we must do is find the water to go up to this line so that we can subtract this number from this number, or sorry, vice versa, this number from this number to get the volume of this balloon. $500 milliliters. 1,000 milliliters. 1,500 milliliters. 2,000 milliliters. 2,500 milliliters. 3,000 milliliters. 3,500 milliliters. 4,000 milliliters. Well, I say that's pretty close there, so I'm just going to use 4,000 milliliters. So what I will do is use 4,000 and then subtract 1,572 milliliters, and that will be my V1 of this balloon. Next step will be finding the temperature of this balloon. I will use my thing here. Here I have 23.1 degrees Celsius. Next, what we must do is place this balloon in a freezer for about an hour. Okay, it's been 1 hour, and I have retrieved my balloon from the freezer, and my temperature is 19.2. Oh, nope. See if that'll focus. No, well, it's 19.2 degrees Celsius. Next, what we must do is find the volume of this balloon. As we can see, the volume, as you can see, has gone down exponentially from this one. It's right about there that we need to make our mark. So I will put a little piece of tape there to measure that off for us. Well, now we know that that's our volume. So what we will do is take our 1,572 milliliters and just keep adding more water to it until we get up to this line right about there. It's 1,000 milliliters. That is 1,500 milliliters added to our 1,572. So that means that when we subtract, or no, we have to add 572 and 1,500 together, and then subtract 1,572 to get our new volume. That was all the data that we needed for that experiment. So now what we must do is go figure out the percent error in our experiment. See what happened. So I went back to our second experiment, and it turns out we had a little bit of an error in our volume reading. Our volume reading was actually 1,672, not 1,572. So I'm just going to put that out there so that we know what happened. Now to find percent yield of the volume in Charles' law experiment, we take our equation and we fill it in with the data we got. This is our volume 1 and our volume 2 as proved by our volume testing and our thermometer. And these are our actual findings in the experiments, actual results. So now how do we find the theoretical? Well, what we do is we take the pre-experiment readings, which are the same as V1 and V2, and be equal to whatever we're trying to find to see if it's right. So we have X milliliters because we're trying to find the theoretical volume. We put it over the temperature of what we had in the experiment. So now what we do is we just do the steps to solve for X, and what we find is that our theoretical value is 1,389.7 milliliters. Okay, so now what's the percent error? Well, percent error is theoretical minus experimental divided by the theoretical times 100. So what we do is we just fill everything in. So we have our theoretical, which we found here, minus our actual and our results, divided by the theoretical, which we have here, which equals 0.079, and we have to times that by 100 to get percent, which means we have 7.9% error. The materials we will need for this experiment are balloons, duct tape, a glass measuring cup. This one reads to 500 milliliters. A large glass bowl. And a 5-gallon water bottle that I constructed to have a barometer on the inside so that I can get accurate readings of pressure. What we must first do is take our P1 and V1 measurements. P1 will be 1 atmosphere, which is calculated on the barometer on the inside of this 5-gallon water bottle. And that brings us to our next measurement, the V1. 5 gallons is 18.27 liters. Next, for setup, you take your water bottle and you put the balloon inside out and place the balloon over the lid of the top. The next step will be cut a hole towards the middle of the water bottle to allow the air to escape, allowing the balloon to blow up. What we will be doing is blowing up this balloon, and then as soon as we finish blowing up, to cover the hole that you made and then observe what happens. As we observed, the balloon inside the container kept it shaped after we plugged the hole because the pressure on the inside of the container was higher and the volume was lower. That proves Boyle's law that when pressure is higher, that means the volume is lower. Because when we were blowing into this balloon right here, we lowered the volume on the inside, in turn rising the pressure. When I took the reading from the barometer, I got a reading of 800 torr, which means that the pressure is higher than the atmospheric pressure, which 1 atmosphere equals 760 torr. Now to find the V2 of our equation, I have a balloon that is the same size as when it blew up on the inside of the water bottle. In order to find the volume of our balloon, we will use a large glass bowl and a measuring cup to measure out 1,500 milliliters of water. That is 500 milliliters. That is 1,000 milliliters. And that is 1,500 milliliters. Next, what we will do is we will take a piece of duct tape and mark off exactly where 1,500 milliliters is, right there. Next, what we will do is we will take our balloon and fully submerge and we see that it goes almost to the top, just a little bit from the top. So what we'll do is we will mark off right about there. Okay, and we will take our measuring cup again and we will fill up, see how much water it takes to get to there, and that'll be the volume of this balloon. This is 500 milliliters going into the bowl. This is 1,000 milliliters going into the bowl. And this is 1,500 milliliters in the bowl. And this is 2,000 milliliters. And that was an extra 120 milliliters of water. So that puts our new volume of our balloon as 2,150 milliliters of water. Let's take a deeper look into our results. The percent error of the Boyle's Law experiment. The measurements from the lab are the P1 is 760 torr, or 1 atmospheric pressure. The volume was 18.23 liters. The pressure 2, as of read off the barometer, is 800 torr, or 1.05 atmospheric pressure. The volume 2, the way we found that was we took our original 18.3 liters and subtracted it from the volume of the balloon and got 16.08 liters as the new volume. So what is the theoretical of the volume? By using P1V1 equals P2V2, we can simply replace our actual yield of volume with X. So we take our 760 torr times 18.3 liters equals 800 torr times X liters. When we do the algebra to solve for X, we get that it's 16.89 liters is our theoretical volume. So what is the percent error? Well, percent error is theoretical minus experimental over theoretical times 100. The percent error then would be 16.89, which is our theoretical, minus 16.08, which is our actual, divided by 16.89, 0.89, which is also our theoretical, times that by 100. So in the end, when we finish all our calculations, our percent error will be 4.80% error.